Hi, I'm going to talk about my second learning object, which is my circuit simulator. Now, the circuit simulator that I have in mind is very similar to the one that is offered through uh, the University of Colorado at Boulder uh, physics simulator website, PhET. That's PhET. They offer a whole bunch of simulators, physics, math, chemistry related, biology related, and they have a circuit simulator there that is pretty good. Offers a lot of options for the kids in building the circuits, but the one that I really would like to create, it would be a flash-based simulator. I think what would benefit the students more is having the option of circuits that are pre-built for them, so they can almost select like module 1, module 2. The biggest thing that my students tend to struggle with is one, the actual circuit components and what they look like, and then two, understanding when we look at a circuit where we actually taken the measurement from. So we'd have things like a battery, and I would use circuit actual schematic diagram symbols to in my program so the students become more familiar with them. These squiggly lines represent resistors, and then you just have your typical wires. Other components that they would then be expected to learn to use would be a voltmeter and an ammeter. The voltmeter for measuring voltage, and the ammeter, which measures the current in the circuit. Now, the two different types of circuits that they'd be looking at are series and then parallel circuits, which have a slightly different appearance to them. And what I would do is, so this is the, sorry, let me, this is the parallel circuit. What I would be looking to do with my program is give them a series circuit, like the one on the left, and provide it with two different resistors. Start them off with a small series circuit of just two resistors, and then have them measure the current and the voltage. Have them measure the voltage across a resistor. So let me get rid of this stuff so I can show you. They'd be able to take, for example, the voltmeter. They'd be able to take the voltmeter and hook it up, give it like little leads, like an actual voltmeter that they could use in the classroom, and let them connect it across a resistor so that they can get some sort of voltage reading. And then they could move that voltmeter to the other resistors. So I'd say, hey, figure out what the voltage is across each of the resistors, and then figure out what the voltage is for the entire circuit. And then ask them, what's the relationship there? And this would be a better way to introduce, use this almost as like the introductory type learning tool, learning object for them. Once they figure that out for a series circuit, I'd have them go repeat that then on a parallel circuit. They'd be doing the same thing of setting up the voltmeter between the two circuits. And this would all be plug and play. They'd already have the circuit built, but then they would get to add these other components in the voltmeter and the ammeter. For the ammeter then, they kind of be doing the same approach. That one's going to be in blue. They would have to take their circuit and say, okay, ammeter is measuring the current. Current passes through the object, so we want to be able to see what's coming out of it. So they'd have to take that circuit and break it apart and plug the ammeter right in there. So they'd have to add it in line with the resistors to figure out how much current is actually passing through each of the resistors. So we want to go through the resistor, so that means the ammeter is going to go after it. And then when they get done, they'd go back to the beginning, back to where the battery is, and say, well, how much current is passing through? So they'd have to look at either the current that's leaving the battery or the current that's going into the battery. And they go and repeat the same thing. Find the current through each of the resistors. Once they did this with the first set of circuits, I'd give them another series and another parallel circuit to look at. Maybe, again, use the same level of resistors. Use, I guess just easy numbers would be good to work with, like a 4 ohm, a 5 ohm, and a 6 ohm resistor, and use the same ones in the parallel circuit, just so that they're sticking with the same numbers so they can make better relationships with them, better connections between the data. So the resistors would stay the same, but your total resistance would be different in both circuits. Then they'd be able to make new connections with the material. They wouldn't do this one time. I'd give them a new set of resistors and maybe a bigger circuit, maybe one with 3, 4, or 5 resistors in both the series and the parallel circuit. So they do, maybe 4 modules. I'm thinking four individual circuits, 2 series, 2 parallel, and then once they have done, sorry, the mouse is not working. Once they've gone through the individual parallel and series circuits, then I'd have them go back and say, okay, now we want to work with a combination circuit. And this is where most of my students in the past, by doing my regular lab, have fallen apart. They kind of get really confused with the material. So a combo circuit is part series and then part parallel circuit. And we'll throw another resistor in there. So they'd be given a circuit like this, and now they would know, like in a series circuit, at this point, I can let them, they could be using their notes that they've been taking, or somehow have like a little help window off to the side that they can click on to know that in a series circuit, your total resistance is just adding together the individual resistors. Whereas in a parallel, the total resistance is actually an inverse of the resistors. So they would know that. They'd also know that in a series circuit, the current is equal throughout. Every resistor would have the same, whereas in a parallel, the current adds up to the total. And then voltage in a parallel is equal throughout, while voltage in a series circuit adds up to the total. So they kind of, series and parallel circuits, they kind of work opposite of each other. So then I'd be asking, okay, now that we know this is how a series circuit works and this is how a parallel circuit works, apply that to this combination circuit. And I'd be asking the same thing. So they'd go back and say, hey, take a measurement. Oh, sorry, red was the voltmeter. So take a measurement of the voltage across each resistor. So they'd be going back, measuring the voltage across each. Then I'd have them go back and say, okay, figure out what the current is through each circuit. And with those, then I would ask them to explain, okay, what is happening to the voltage and current in the circuit. So they'd get this, maybe this would be the first circuit that they would see. They'd be able to take these measurements, record their data, see how it relates back to the battery, and then they would get a second set of material another combo circuit and get to compare their answers with. So the best part of this is being that it's a flash-based simulator. I'd keep it pretty set on there'd only be a handful of circuits in there, but within those actual circuits, they'd be able to repeat it multiple times, retry their ideas, and even be able to change the resistor value so that they can see different sized resistors working with each other and see how they relate.